Today we are looking at lesson 6.4, and really it has to do with one theorem, 6.4. Learning targets, students will be able to use mid-segments of triangles in the coordinate plane. So before we even look at it, if we have a triangle, what do we think the mid-segment would be? That's a small and not very straight triangle. Let's just take a guess. We have this triangle. What do we think the mid-segment would be or have to do with? The midpoint of what?
Each segment.
Yep. Good job. Mid means middle. Segment would be like here. Okay? Mid-segment. Good job. Students will be able to use the triangle mid-segment theorem. So we have one theorem to find distances. Guess what's coming back? Distance formula. Better believe it.
I use this formula.
Good. Wait, you said you use it a lot?
Yeah.
Sweet. Order of operations. We have a term, a example, a theorem. And then this last example that has to do with proofs, we're skipping. Because we are not, at least today, going to be proving this stuff. So here's your term. That would be a good picture to get down. A mid-segment of a triangle is a segment that connects the midpoint of two sides of the triangle. Every triangle has three mid-segments, which form a mid-segment triangle. So just like we said, a mid-segment of like line A, or segment AB, would be that midpoint, line M. And then what they take it even further to say is that if we connect each mid-segment, we have what is called the mid-segment triangle, which kind of makes sense. Out of all the terms that we've looked at so far, this is probably one that makes the most sense, or that comes most naturally. If you didn't guess it already, we'll be using the midpoint formula. We'll have to do things to find like the midpoint between B and C. And that would give us point P, and then we'll have to use some distance formula to find the distance between like P and M, and a lot of other cool stuff like that we've already learned. I'll give you like another 30 seconds to get that down. Also, as a side note, I've had some people ask why it looks like I'm wearing dark circles under my eyes. I did not get beat up. I got hit in the face during basketball practice. Arm across the face. But I didn't do it to myself.
You get beat up?
No, I didn't get beat up. Trust me. If I would gotten beat up, I'd have a picture of the other guy. But knock him out. Yeah. No, I didn't get beat up. I got hit in the face, and now it's dark here and here, darker here, and then it's turning like a nasty.
Who did it?
Well, it was on accident, so it doesn't matter.
Well, so you just know that.
So you know not to be like that.
Yeah.
All right, here's an example. In triangle JKL, that triangle right there on our screen, right here, that triangle. Show that the mid-segment MN, okay, right there, is parallel to M, and parallel to J. Well, let's start there. That's the first thing we need to do. Now, how would we prove that these two things are parallel? Yes, Jack.
You compare their slope.
Yeah. So we need to find the slope of MN. Well, does it tell us what what are we going to have to do first to find where point M is?
Use rise over run.
Well, we're going to do that when we find the slope, but we need to find first the point. We need to find where point M is. Yeah, Anastasia. We could, we could count the boxes, look, because that looks like it is right on that line, right where they cross, so we could find point M. But what if it's like 0.1 up? You never know it. So what do you think we have to do? We have to use the midpoint formula. Yeah. So to find point M, the first thing we need to do is use the midpoint formula. So to find point M, let's see, J, the x values, right? The midpoint formula is add our x's, divide by 2, add our y's, divide by 2. Okay? Finding the middle, or finding the average of our x's, average of our y's. So if we look at J, the x is -6 plus -2 would give us -8. -8 divided by 2 would give us -4, which looks like it makes sense. -4. We have to add our y's, 5 plus 1 divided by 2. So let's see, 5 plus 1 is 6, divided by 2 would be 3. Awesome, which does 3 make sense? Yeah, that makes sense. Now we have to find where point N is. Let's see, so it's between K and L, so -2 plus 2 would be 0, 0 divided by 2 is 0. I think somebody said that. The y value of K is 5, y value of L is -1, so 5 plus -1 is 4, divided by 2 gives us 2, which that looks to make sense, right? Up to, or doesn't go anywhere left or right, and 0, up to, that checks out. So good job, we just found those segments. Now, like Kylie said, we need to use rise over run and find the slope of MN, right? Because the question asked, is MN parallel to JL? The way that we're going to see if those two line segments are parallel are by testing their slopes. So if we look at the rise from N to M, it is -4. The run is just 1. No, that's just 1. No, I switched them. Let's do that again. The rise is 1. The run is -4. There we go. So we have a slope of 1 over 4 for MN. Now let's look at JL, the slope of JL. Let's see, the rise from L to J is so the rise is 2. What about the run? -8. So that would simplify to -1/4. So our slopes are the same. So show that it's parallel. Boom, we showed it. Nice job finding the slopes. Now the second part. That MN, so this, is half of JL. Okay? They want us to show that it is half of JL. How would we show that? Distance, yeah. No, we can't count it. It cuts through boxes. We can only count vertical and horizontal lines. What? We cannot count those. Okay, here we go. MN. Who remembers the distance formula? What does it start with, Anastasia? Was it minus?
Yeah.
Is it minus?
It's square root of
It really wouldn't make a difference if we put x1 or x2 first, as long as we stay consistent. Squared minus y2 minus y1. This should be plus the quotient. Squared. All under the square root. So let's call these our 1s. Let's call these our 2s. And why don't you guys go ahead and find the distance of MN? Go ahead, distance formula, distance formula, distance formula. Will, let's go with distance formula. Hey, I like that you're being involved. Trust us. Distance formula. Let's go. Let's go. Using your knowledge. Let's go with distance formula. Come on. You got it? Is it 4.1? Yeah, I would like, so that brings up a good point. I want the square root. It's the square root of what? Square root of 17. Agree? Disagree? Not sure yet? Don't care?
I agree.
I also agree. Now we need to find the distance of JL. You can't see, there are the points. You can see those a little more clear. Go ahead, find the distance of JL. Are you guys doing the distance formula? Guys, distance formula, let's go. Let's see, that would be 8. Will, is this what you got? Pretty close. What did you get?
70.
You got what? 7? Where did your work go wrong?
I'll be on the second step.
What did you do instead of this?
I mix them up.
Which one, like what? Did you make this positive on accident?
Flip them around.
Flip them around? Well, that wouldn't make a difference in your answer. Didn't use a calculator. Hey, I'm picking on Will, but at least half the class isn't doing jack squat during our warm-up or during the lesson. So if you want me to start taking a grade on everything, I can. That would be like very second grade-ish. But maybe a lot of us, and again, I'm picking on Will. It's not Will. Well, it is Will, but it's a lot of other people too. You guys kind of got to get crap together a little bit and do these problems. Even if you say you already know how, or say you can do it in your head or whatever. Part of learning. Otherwise, I will start taking them for a grade. Or do participation grades every day. That would be really annoying. So, if we look at, where did I put my pen? There it is. If we look at the distance of JL is the square root of 68. Now, if we just look at these two square roots, is there any way that we're going to be able to know if the square root of 17 is half of the square root of 68? Like, divide 68 by 2. I like the way you're thinking, but we can't just divide 68 by 2 right away. Okay? You're on the right track. but not exactly what I'm looking for. If we type these in our calculator, we'd be able to see. But if we didn't have a calculator, we reviewed this a little bit with my geometry class at the end of A. But how can we rewrite the square root of 68? Do you guys remember? If we want to simplify a square root, we can rewrite it as two things multiplied by each other, and one of them we want to be a perfect square. Well, is 8 a perfect square? 6. Yeah, I see where you're coming from. We could not do that. So our perfect squares are what? 1, 4, 9, 16. Do any of those fit into 68 that we can multiply? Blank times what? Perfect square times what? Our perfect squares. This goes back to a little algebra review. 4 times what? 4 times 17? 4 times 17 gives us 68. Now what can we do with that 4? Right, we can square root it. Make it a 2. Now, is it pretty obvious that the square root of 17 is half of 2 times the square root of 17? Yeah, isn't that cool? You don't even need your calculator. You can just find it on your own by factoring out the perfect square. What I would like to see for your answers would be the square root here and your simplified square root right there with your perfect square rooted and taken out. This is a good algebra review. Also, you're going to have to do this again in Algebra 2, except with cube roots and fourth roots. So we need to nail square roots. If you need a little extra help on that, we can do it. Okay, cool. Anyway, Theorem 6.8. So here's a theorem for all this. And then that's it. And then we have our class cake. Which I think I may put the code on there, but I don't remember actually doing the question. So we'll find out when we get there. So here's the theorem for all of it. The segment connecting the two midpoints of a triangle is parallel to the third side. Okay? So this mid-segment, D, like it says here, is parallel to that third side, AC. Okay, that's why they were asking us in this question up here. They're asking us to show those two things are parallel. Not only is it parallel, but it is also half the length of that side. So DE is parallel to AC. Also DE is 1/2 of AC. And that is what your homework is going to consist of today, or 99% of it. Of showing that those two lines are parallel and showing that the mid-segment is half of the third side. And by showing, that means showing all your work. So show the distance formula, show those square roots, simplify those square roots, all that good stuff. Show our slope. Do we need another second looking at this, or are we good? Another second?
I'm guessing that.
What? Dang it. Yes. that's all our new learning for today. Not too bad. It actually isn't anything new, right? We just put in the term mid-segment. But we have done distance formula over and over. We've done mid-segment, or we've done midpoint a lot of times. But now we're just calling it the triangle mid-segment here. They do get into writing proofs with this. But we are not going to get into that today. So we might in the next week, but today is going to be pretty relaxed. So, class kick.
I think there's only, actually, like I said, I don't remember if there actually is a class kick that's on there. Hopefully.
Type that code in and see what comes up. Does it really?